Welcome back. So now we see how we should define the tangent line and its slope to the graph of a function at a given point. So let's say that I have the graph of the function f of x in black ink, and we are fixing the point a f of a on this graph. And we want to define the tangent line in red, and its slope to this to the graph at this point. So how do I define the tangent line and its slope to the graph of the function f at this point? Well, so to do that, what we're going to do is we're going to change a by h. So, and then look at the point a plus h comma f of a plus h. So let's say this is the point. This is the point with coordinates a plus h and f of a plus h on the graph of the function. Let's look at the secant line in blue between these 2 points, and let's ask ourselves, what's the slope of this secant line? Well, this is the line, and we know we have 2 points on the line, so the slope would be rise over run. And so the slope of the secant line is f of a plus h minus f of a divided by a plus h minus a, but a plus h minus a is just h. So the slope of the secant line then is f of a plus h minus f of a over h. Okay, so that's the slope of the secant line. Now, notice or observe the following. If we allow h to approach 0 now, what's going to happen is that this point is going to get closer and closer to the point a f of a. And so as a result, when h goes to 0, the blue secant line is going to tend to coincide with the tangent line. So then we should say, okay, let's take the limit of this limit of the slope of the secant line here as h goes to 0, and if the limit of the slope of the secant line is defined as h goes to 0, then we say that the tangent line is defined at the point a f of a, and its slope is given by the limit of this ratio. So the slope of the tangent line at x equals to a is the limit of this difference quotient as h goes to 0. So once again, I want to emphasize that what we are saying is that if the limit of the slope of this secant line is defined as h goes to 0, then the tangent line at the point a f of a is defined, and its slope is given by the limit of the slope of this secant line. So for y is equal to f of x, the slope of the tangent line to the graph of this function at the point a f of a is given by the limit as h goes to 0 of f of a plus h minus f of a over h. And the tangent line to the graph of the function at the point a f of a is the one passing through it with this slope. Okay, so now you can see there's this limit that we have, the limit of the difference quotient. Remember, we looked at the difference quotient before we even looked at limits, and we did that exactly because this is an important quantity. So in the previous video, you saw that this limit gave us the instantaneous velocity of a moving object at time A. And in this video, we see that this limit is also giving us the slope of the tangent line to the graph of a function f at the point a f of a. Okay, so in the next video, we will look at an example where we will compute the slope of this function at the point 3 comma negative 3. Okay, so I'll see you in the next video.